Welcome back to my channel. My name is PrachiSharma and this series is for ISC students, chemistry for 11th grade. Now, the first session was already covered. In today's session, we'll be discussing more about molarity and what the entire topic is about, what kind of formulas we have, how do we derive those formulas, and understanding the concept. Students, if the concepts are clear to you, I can assure you any kind of numerical that may show up, you will be able to do it. So focus on understanding the concept really well. If you have any doubt that you studied a concept but you're not sure about it, so just try to explain that to a friend of yours, or if nobody is available, ask your sibling to sit with you for 10 minutes. If that is not possible, then ask one of your parents to sit with you, because they'll be definitely happy to help. Try to explain the same concept to them. If they are able to follow through and repeat after you, then definitely your concept is clear. Since the syllabus is vast for 11th grade, please make sure that you are putting in enough efforts from the beginning. It is not like 10th grade. You may get a shock after the first examinations that may happen in the school. So please, I am warning you in advance and I am asking you to stay on point with the syllabus from the beginning. This cannot be done at the last minute. So make sure that you are utilizing your time well. You're working on the concepts well. So without wasting any time, let's get started with today's session. So students, I hope my screen is clearly visible to you. Let's take a quick recap of the last portion of our session. So we discussed about molarity towards the end of the session, and there was no homework, so I do not have any homework questions for you today. So let's quickly take a short recap of that, and you can repeat after me if you remember that. So keep repeating and keep writing, okay? That will help you stay on top of the concepts. So let's get started. So we were talking about molarity, and we did do a few points on that. So the first point we did was that the formula for molarity. First is molarity is denoted by capital M. Capital M is equals to N upon V. Okay. And what was N? N was number of moles. Number of moles of what? Of solute. And what is V? V is volume. Now, volume of what? Volume of solution. And what is the unit for this particular volume? That is in liters. Okay, so this is the formula that we covered. And why is it important and why am I specifically mentioning liters? Because in whatever we discussed before molarity, we were always taking volume as milliliters. But for the formula of molarity, you have volume in liters. So if your question gives you a volume in milliliters, you convert that into liters by dividing it by 1000, and then you utilize that in this particular formula. So this is what we discussed. This is what the formula we discussed was. Okay. So repeat after me. We had N. N was the number of moles of what? Of solute. V was the volume. Volume of what? Solution. And in what unit? In liters. If the question is giving us volume in milliliters, we convert that into liters by dividing it by 1000. Now let's move forward. Now what is N? What is the formula for number of moles? So N was equal to weight in grams over molecular weight. And of what? So if you're calculating number of moles of solute, then you do the same thing for both of them as solute. That means weight in grams of solute and molecular weight also of solute. If you are calculating for solution, then weight in grams of solution divided by the molecular weight of solution. Okay, so this is very important for you to understand. For example, if I give you, let me take an example. Let's say you have glucose and you are dissolving glucose. So glucose dissolved in water, and I tell you that that glucose weight is 360 grams and the molecular weight is 180 grams, and for water the weight in grams I have is 36 grams and molecular weight I have is 18. Molecular weight, and you have to calculate the number of moles of the solute and the solvent. So in this case, if you understand, so glucose is your solute and your water is your solution, or you can say solvent, combine them as a solution. So let's talk about it. When we are calculating the number of moles for glucose, so that will be N equals weight in grams divided by molecular weight. So if that happens, so that will be 360 divided by 180, which will give you 2 moles. So glucose has 2 moles. Okay. Now let's try the same thing for water. So when we are calculating for water, N will be 36 over 18, which will be 2. Okay students, please try this out at home also. Keep trying out questions and practicing. Now, this was the first thing. This is the second thing we did. Okay. So we talked about the formula for molarity. We talked about its conversion to liters. We talked about the formula for number of moles. And after that, we also talked about the temperature. So, molarity is temperature dependent. Let's name them a bit. So let's start with the formula. It's A. Then let's say the temperature part is B. Okay. So molarity is temperature dependent. Whenever we have volume, any formula that contains volume, that particular formula or that particular identity that you are calculating will be temperature dependent. What do we mean by this? So I told you that you can write temperature here, volume, and you can talk about molarity right here. So let's quickly write the formula for molarity once again. So molarity was equal to N upon V. So what is N? So let me just write this as solute and this is solution and in liters. Okay. So when we talk about V, so you can see that V is inversely proportional to molarity. So let's see, when temperature increases, volume increases. But since volume and molarity are inversely proportional, so molarity will decrease. Similarly, if temperature is decreasing, volume is decreasing, your molarity will increase. Okay students, so this is what we discussed in the last session. Now we are moving forward from here. Now, let's say I have 3 samples. So I have acid 1, acid 2 and acid 3, and I combine these 3 acids, okay, and I get a final sample piece. So this is acid, or you can say, let's call it final. Okay, so this is 1, this is 2, this is 3, and that is our final sample. Now when I talk about acid 1, let's say the molarity is M1 and your volume is V1. For acid 2, let's say it is M2 V2. For acid 3, it is M3 V3. And for the final, you have M final and volume final. So MF and then VF. So this is what it is. Okay. Now if I talk about the number of moles for each of the sections, so we can get it from the formula. We had M1 equals N by V1. That is the number of moles. Let me call it N1. So what is N1? N1 will be equal to M1 V1. That is correct. Let's do the same thing for the second one. Molarity will be equal to number of moles upon volume. So M2 V2. And you can calculate the number of moles as M2 V2. M2 times V2. Let's do the same thing for M3. So M3 by V3, and your number of moles will be equal to M3 times V3. Okay. So this is what is happening. And if you talk about M final will be equal to N final upon V final. So your number of moles N final will be equal to, so let's just use this formula. Now I'm calculating for the final one. So that means M final equals N final upon V final. That is correct. And what is N final? What will happen? If you have acid 1 with number of moles X, number of moles Y, number of moles Z, so your final case will be X plus Y plus Z. So that is exactly what we will do, that we will just add up the moles. Okay. So when you are calculating M final, what you will write? You will directly write N1 plus N2 plus N3. And when we talk about the volume, of course, volume will also get added up. So you will have V1 plus V2 plus V3. Okay, makes sense? And from here, we derive these three formulas for N1, N2 and N3. So we will put that in this particular formula that we have. So what will I have? I will have M1 V1 plus M2 V2 plus M3 V3 divided by V1 plus V2 plus V3. Make sense? And this is what? This is M final. So students, this is the derived formula. Okay. And this is known as, this particular concept is known as mixing. You get a lot of mixing questions and numericals. So this is the formula that works for you. If you do not remember the formula and you are slightly confused, you can directly use this concept. Okay, you cannot lose marks just because you don't remember the formula. You can use this concept and derive your answer directly. That is what a lot of teachers actually expect, that only. In ISC boards, so some teachers have their preference when they have their school submissions. So a lot of teachers I have seen that they prefer that the students derive it and then do the question. So derive it as in, do not derive the formula, but solve the question in this pattern. So this will help you analyze the question well, and there would be very low chances of going wrong. So make sure that you take a look at it again. So let's quickly take a recap of it. So I have acid 1, acid 2, acid 3. I mix all of them together. My first acid has the molarity of M1, volume of V1. Acid 2 has M2V2. Acid 3 has M3V3. And I have M final. Okay. So what will be the number of moles for my first acid? So N1 will be equal to molarity times the volume that we have. That is correct. And we do the same thing for acid 2. We do the same thing for acid 3. What will be M final? M final will be nothing but the addition of these three. That is what is happening, right? M final is mixing three acids. So M final will be, what is my number of moles? N1 plus N2 plus N3. What is my volume? V1 plus V2 plus V3. And whatever you have derived up, that was number of moles, that was equal to M1 V1. You put that in this particular formula. So this is an important formula. You get numericals about mixing. This is the logic we are using in those questions. Okay, students, let's move ahead. So we did the C part. So this mixing was C part. Let's move on to D. So D part is that molarity is an intensive quantity. Now, let's take an example first. So, if I have a solution, okay, I have a solution, let's say it is this much. So, you have solute plus solvent. So, this is your solution, and I have a smaller beaker and I transfer some of the solution in that. Okay, so let's say the molarity of this particular solution was 25. Okay, and let's say this was 10 liters and you transferred 2 liters here. Now the question that you may get would be, what is the molarity of this 2 liters of solution? Because initially the volume was 10 liters. We have shifted it, or we have taken out 2 liters of that volume. So how is the molarity impacted by that? Okay, so this is your question. So think about it, pause the video, give it a thought, and then resume. So I'll tell you the answer. The answer is that, so when I talk about intensive, you can imagine it to be as independent. That means molarity is independent of quantity. It does not depend upon the volume transfer of it. So if your molarity was 25, it is gonna stay 25 whether it is 10 liters or whether it is 2 liters. Okay, because whatever molarity you have calculated, that is gonna stick it for that solution. Whether you have half of it, less of it, or none of it. Like not none of it, but let's say you have transferred some of it. So that is what I mean. Molarity is independent of quantity. So let's write that. Molarity is independent of quantity, that is matter. What is quantity, students? Quantity is matter that we talk about. Okay, now let's move ahead to the next topic, that is your we had E. So I have E. Now next is E. So let's look at that. What is unit of molarity? So unit of molarity. So when we talk about molarity, the formula was, repeat after me, the formula was M equals N upon V. N was number of moles of solute. V was the volume of solution in liters. Correct? What was our unit for number of moles? It was capital M. And what was, sorry, not capital M, it was just moles. I'm sorry. So the unit for number of moles was mole, and the volume that you have in the denominator, the unit for that is liters. So the unit for molarity is moles per liter. This is your unit. You can also write it as M per L. You can also write it like that. Or a lot of books also have them written as capital M only. Okay. So if you have capital M only written, so let's see. If I say that my molarity is 25 and I'm saying it is moles per liter. So this is how you will read it. It is the molarity is 25 moles per liter. If I write 25 M, how will you read that? You will read it as 25 molar. This is how you read it. This is read as 25 molar. Okay, students, I hope it makes sense. Now let's move ahead. So any portion that you want to revise, please pause, take a note of it, get back, revise again. If you're still struggling with it, please do not hesitate to drop me a message in the comment box, or you can also email me at psclassesicse@gmail.com. You can also connect with me on Telegram. Okay, students, please, if there is any portion that you are getting stuck in, you're trying again and again and not getting it, please reach out for help. Do not leave it out for later. Now, let's move on. So this was our E part. Now let's move on to F. Now, what kind of questions also come from molarity? They can ask you, what do you mean by 20 moles per liter, or they can say 20 M, or they can also say 20 molar. So this kind of question can come. They can ask you, what do you mean by 20 molar? So what do you mean by that? M equals number of moles of solute divided by, repeat, divided by volume of solution in liters. Okay, so this is what the formula is. So what will be the answer for this? You will say it means, this statement means 20 moles of solute is dissolved in 1 liter of solution. Okay, so this is what you will write. Or you can also write 20 moles dissolved in per liter of solution. So any of those will work. So what will you write? 20, not liters, 20 moles of solute is dissolved in 1 liter, or you can write per liter of solution. So you can write any of those. If let's say, so a lot of students ask me, ma'am, volume के लिए कुछ नहीं लिखना? So नहीं, volume के लिए कुछ नहीं लिखना. If they say that number of moles is let's say 1 upon 10. Okay, they say 1 upon 10 is the mole. Or 1 upon 10 is your molarity. How will you write that? Convert that into decimal, students. Convert it. So what will it become? It will become 0.1. So 0.1 moles dissolved in per liter of solution. If I say I have 0.20 molarity, so you will say 0.20 moles dissolved in per liter of solution. Okay, do not make mistake with this one. Very simple question, but high chances of making a very silly mistake. Okay, students, let's move ahead. Now, this we did was F. Now, next is, what is 1m? So, I'm trying to give you the units that we have for molarity. So, what is 1m? 1m is molar solution. That is correct. Now, in a molar solution, now what I'm writing I'll tell you, or unity molar. Now, if your question reads like XYZ thing is happening in a molar solution, so when they say this happening in a molar solution, that means the molarity is 1. If they say unity molar, the sentence says it has unity molar in the sentence, this means that molarity is given as 1. So you have to understand the terms so that when you are solving the numericals, you can bring out the information from the numerical. Okay. So 1 molar can be written as molar solution, in a molar solution, or unity molar. If any of these terms are used in the numerical, the molarity is already given to you. It is 1. Okay. If they say it is a decimolar, so decimolar will be, let me write the units for you. So decimolar will be m over 10, or it can be written as 0.1 m, or it can be written as decimolar in the question. If you have, let's say, m over 100 or 0.01 m, that is centimolar. Okay. Then if I have m over 1000 or 0.001 m, this is millimolar. Okay, students. Now next is m over 2 or 0.5 m. This is semimolar or semimolar. Now next, if I have 2m, that is bimolar. Okay, students. So we can also go further. You have 3m, so that can become trimolar. But this is what is important. These units are important for you to understand and remember them. Okay. So let's repeat after me. So I have 1m that can be written as molar solution or unity molar in the questions. I have m over 10 that can be written as 0.1 m, or we can call it decimolar. If I have m over 100, that can be written as 0.01 m or centimolar. If I have m over 1000, that can be written as 0.001 m and can be called millimolar. Similarly, we have semimolar and bimolar. Okay, students, super easy. I hope that makes sense. Now, let's move on to the last portion that we have for today, and very, very important portion that will take a while. Okay, so pay attention on this part. What we did G, H. Okay, now we are working on relationship between mass percent and molarity. Okay, relationship between mass percent and molarity. Okay, very important topic, and a lot of students find it complicated, so please pay attention as we go along. Now let's get started. If I give you P% of a substance by mass, so what do I mean? I mean I have P% of a substance by mass. So when I say this, what do I mean by this statement? So whenever you have anything written as P% of a substance, students, this substance is solute. Okay, this is solute, no matter what it is. Do not care what it is. Understand the statement. If no matter what kind of it is HCl, it is benzene, it is toluene, no matter what the substance is, if the statement is written like this, the language is this, P% of a substance, that substance is solute. Now one important thing, student, why do I keep repeating these things? That is because when you start doing the numericals, the language can confuse you what the solute is, what the solvent is. Okay, what kind of information we can take out from the question can be slightly confusing. So pay attention and understand it. Okay, P% of a substance by mass, this particular substance is gonna be solute no matter what happens. Okay, alright, now let's move forward further. What do I mean by this now? So P% can be written as P over 100, correct? And I remember from the percentage that we discussed in the last session that P over 100, both of them are in grams because we are talking about mass. Okay, so what is P? P was solute of mass, or sorry, mass of solute. Mass of what? Mass of solute. And what is 100 grams? It is mass of solution. Okay, so this is what we have. Now let me give you an example. Let's say I have 30% of a substance. What all information can I get from this? So I have 30 over 100, correct? This is mass of solute. This is mass of solution. So let me write that. I have mass of solute as 30 grams. I have mass of solution as 100 grams, and my mass of solvent is equals to 70 grams, students. That is correct. So when you read the statement 30% of a substance, you already have so much information about that particular substance. But please, 30% of a substance by mass, okay, I'm repeating it. If it is by mass, then this particular concept works. If it is by volume, then I'll teach you what will work. But if it is by mass, this concept is gonna work. So just one statement can give you a lot of information about it. Now let's move on. Now let's talk about molarity. So when I have M, students say out loud, what was the formula for molarity? That was N upon V. And this was number of moles of solute, the volume of solution in liters. Okay, this is what the formula was. Now if I ask you the formula for N, what was the formula for number of moles? So that was weight in grams divided by molecular weight. And we used to do that for the same type. That means if you are calculating for solute, these both the things will be for solute only. Correct? Now, since this is for solute, can I put this number of moles formula and put it over here? I can do that, right? So let me write that. So M equals weight in grams divided by molecular weight of solute. that is right, times 1 upon volume, and this volume is in liters and this volume is of solution. Now students, by whatever information we have so far, do we know the volume of the solution? Do we know it? Can you take a look at the whatever portion we have covered? Do we have the volume of solution? Now a lot of students I have seen will tell me, ma'am, it's 100 grams. So students, know that is not the volume of the solution, that is mass of the solution. Two separate things. Okay, so we do not have the volume of the solution so far. Now let's look at it. Now our entire energy should be focused on how to find this volume of the solution. So how will we do that? Whenever they ask you such a question in which they need you to calculate the volume of the solution, they will always give you the density in the question itself. Okay, so let me write that for you here. Now let's simplify this a bit. Now weight in grams. Now what was the weight in grams? I had taken P. So this particular thing will be P grams. So I'll just write P in grams. The molecular weight will be given in the question. So I am just writing given times 1 upon volume of solution. And this part we do not know. Okay. This we do not know. How will we figure this out? We'll figure it out from the information given in the question. The question is talking about density. Okay, so I'm just gonna write that small statement for you. That is, let me use a darker color. That is, we do not know the volume of solution. Okay, we will get it from density given in the question. Students, why am I writing this small detail for you? That is because when you're revising this during the examinations, you should know what you were doing in this particular derivation, or how is the relationship working. Okay, so that is why I'm doing it. Make sure that all your notes are very minutely made and you have all the information, even if you're writing small notes around the sides. Okay, now let's move on. Now when I talk about density, so density can be given. So let's say density of solution is given. Okay, now when they give density, always look at the unit that they have given. Okay, sometimes they will give you D as grams per milliliters. Majority of the cases you will have this grams per milliliter, but we do understand that the volume that we want should be in liters, because that is what we have been repeating throughout the session today, that we want the volume in liters. So what we will do, whatever density you have got, you divide that by 1000 and you convert that into liters. Okay, so let's do that. So first of all, let's start from the beginning. So the first thing is that you have the density given G, and that is your 100 grams, because that is what the mass was, right? Let me write that for you in the detail. So density is what? Density is mass upon volume, and since this density is of solution, so mass of solution over volume of solution. Correct? Density of the solution is given to you as D grams per milliliters, and this mass that we have for solution, we already have that here. The mass is 100, right? So you put that 100 there. So 100 upon V, and this is in grams, and this we need in liters. Okay, so what will happen here? So for when you're using, like when you're doing this question, you're taking that in milliliters, later we convert that. So this particular grams get cancelled out, correct? So what is happening? You have your density D as 100 over V, and you can write V as 100 upon D, and this is in milliliters. That is correct. So when you have that in milliliters, what will happen? You convert this into liters by dividing it by 1000. So 100 over D times 1000 is in your liters. This is your volume that we had been looking for so far. Cancel out these zeros. You will get 1 upon 10 times D liters. This is volume of solution. Let's put it in a box. Let me write volume of solution. So we were looking for this so far. So let's mark this as an equation. Let's say equation 2 or equation 1, whatever you want to mark it as. And you go back up on the previous page and use this information and put it back in that formula. Okay, students? So let's do that. So I had M equals, I had P in grams divided by, I had the molecular weight given. For now, I'll just write molecular weight. Molecular weight, and both of this information I have is for solute, times I had 1 upon volume, and volume is what? 1 upon 10 times D. So that will get reciprocal. So when I say 1 upon, and this was V, so this was 1 upon 10 times D, right? So this will go up in the numerator. So this will become P over molecular weight divided, this is for the solute, times 10 times D. Okay, so now let's make the formula that you have. So this particular formula, what will that look like? This will be P times 10 times D, or P times D times 10, whatever you want to write, divided by molecular weight, and this is for solute, and this is for solute, and this density that you have is for solution. Okay, students, this is the one that was given in the question. Now, I hope this makes sense to you so far. We will revise it again. So, take a good look at it. Take a minute, pause and take a good look at the entire thing, and just pause the video for 10 seconds and just go through it real quick. Once you go through it real quick, then I'll again revise it with you. So let's quickly revise now. Go in steps. Okay. When you revise, always revise in steps. The step 1 was, and this revision is for, this is for P% of a substance by mass. So let's quickly revise this. So when I have P% given to me, I'll figure out the information that we have. So P% means P by 100. And this is in grams, this is in grams. This is mass of solute. This is mass of solution. Then the second thing, molarity formula was N upon V, correct? And I was able to figure out the formula for N, that was number of moles, that was weight in grams, divided by molecular weight. And both the things were for solute, times 1 upon V, this was for solution, and it was in liters, correct? We were this far. And then we realize, okay, I do not know the volume of the solution. So we go back to the question. We identify that in the solution we have density given. Density of the solution is given. And this is given in what? This is given in grams per milliliters. Okay. So let's see. When D of the solution is given, density is what? It is mass upon volume. And all the things are about the solution. So the mass that you will put here will be mass of the solution. In the first step, I found the mass of the solution as 100 grams. So D will be 100 over V. That is correct. So your V will be 100 upon D, and this entire volume that you have is in milliliters. I'll just write ml. Correct? This is your volume. We convert that into liters. How will we do that? Divided by 1000. So 100 over D times 1000. So what do I get? I get 1 upon D times 10 as the volume of the solution in liters, and this is in liters. Okay, so let me quickly write that. Volume of solution in liters is what? 1 upon D times 10 liters. Correct? Let's put that back in the second point. So this is your fourth point in which you are putting it back in the question, or in the second point. So let's quickly write that. So that will be what? This will be M equals mass in grams divided by molecular weight, and this both the things are for solute, times 1 upon volume in liters for the solution. So let's write that. Mass was our P. So molarity equals P over the molecular weight of the solute times 1 upon D times 10, that was our volume. So let's move on. M equals P upon molecular weight times D times 10. So what is our final formula? The final formula that we have is P over molecular weight times, let me write it properly. This will be P times D times 10 over molecular weight. This is your final formula. What are the conditions for this formula? The P that you have is P% of solute by mass. The density that you have is given in grams per milliliters, and the density is also given for solution. All these three things are your condition. The molecular weight that you are using here is for solute. So this is your final formula with the conditions that your molarity equals P. The P is percent of solute by mass times D, that is your density of the solution given in the question, and the unit that you have is grams per milliliters. The molecular weight that you are using in the denominator will also be given in the question, and this particular molecular weight is for solute. Okay students? So students, this is it for today's session. The reason I am going at a very slow pace with the topics are because they are very important topics. You get a lot of numericals, and a lot of information can be confusing for you to understand, to remember. So as I'm going at a slow pace with you, I know you have a whole year ahead of you. I am not in a rush right now. And when we are doing the revisions, in the revisions we'll have a very fast pace of doing the questions. But right now, since you're doing the questions, doing and understanding the concepts for the first time, take your own sweet time, understand them well, and then move on. Okay? So there is no hurry at the moment. I am giving you enough time, enough details in the videos, and if still you feel there is certain portion left out, I don't mind doing that again. So let me know that. Go through the reference book. So for example, if you're taking reference from Newton, take reference from that book and go through the syllabus as we go along. Keep matching up. Whatever is given in the book, are we covering all the concepts or not? Once I finish the series for the first chapter or the first unit, then tell me. Okay, because I still have a lot of videos coming out and I'm covering small portions in every video. So once the series is completely out and you still feel that some portion was left out, then definitely let me know. A lot of students emailed me asking about any other reference book that they may need. So my suggestion would be that first cover up what you have in the syllabus right now. First master that and then take up any reference books for IIT JEE. Do not start doing everything all together. It's gonna mess up. Complete one unit entirely, the concepts that I'm teaching, the questions that I'll be discussing, plus your book. That is, for example, you are following Newton, somebody else is referring to some other book. First master one book and then pick up another book for reference. So first master what is going on right now. Do not try to take up all the content and mess up your knowledge, okay, and get confused in so much. So first master what you have right now. I will be doing a lot of competitive questions as well, so you don't have anything to worry about. My only suggestion is to keep up with the syllabus from the beginning and cover up the portions, practice the questions from your book, and leave it up to me. I will make sure that everything is covered for you. Okay, students? So don't be worried. Let's stick around with the series. Make sure that you're sharing this video with your friends and also subscribe to the channel. We will catch up in the next session.